Hi guys, welcome to JAMATHS Teach, where maths is a must. And the topic that we'll be looking at today is laws of indices. And I know that you would have already been introduced to indices, so let's get into it. Just a few reminders. If you are given a to the fifth power, a is the base, and the 5 is representing the power or index, otherwise called exponent. If we're given a times a times a times a, then we can represent it in index form by counting the number of times a is being multiplied. So that's 5 times, and we write it as how it is right here, a to the fifth power. So the index tells the number of times a number will be multiplied. So our objectives for today is to investigate the index law of multiplication and division, investigate the index zero law, investigate the index law of power to power, and also to investigate the negative index law. Let's look at an example under the multiplication law. So if we're given 2 to the fourth power multiplied by 2 to the third power, then the long way, if there were no indices, would be to write out 2 multiplied by 2 4 times, and then multiply that by 2 multiplied by 2 3 times. And count them 1, 2, 3, 4, 5, 6, 7. And we'd say, okay, that's 2 being multiplied 7 times, so it is 2 to the 7th power. If we had a to the 7th power multiplied by a to the 8th power, then we'd have to write out a being multiplied 7 times multiplied by a being multiplied 8 times, and then we'd have to count all of that, and we would get a to the 15th power. But in times like these, does it really make sense to spend so much time writing out things? No, we have the laws of indices. That is why we have the multiplication law, right? So the multiplication law of indices, based on what we just observed as well, instead of writing out 2 times 2 times 2 times 2 times 2 times 2 times 2, we simply keep the base and add the powers. So then we'd end up with 2 to the 4 plus 3 power, which would give us 2 to the 7 power. No stress of writing out 2 7 times, right? Because could you imagine counting all? What if you had a power of 100 and you had to write out that number being multiplied 100 times? Nothing this time. So then the indices multiplication law is that when multiplying indices with the same base, we keep the base and we add the powers. As you can see right here, we kept the base 2 and we added the powers. 4 plus 3, 7. So we end up with 2 to the 7th power. The division law. First thing you do is to, for the long way, is to set out your division as a fraction. You know that the first number is your numerator and the second one is your denominator, right? And the bar means divided by. So 5 to the 6th power, for the long way, you write out 5 times 5 times 5 times 5 times 5 divided by 5 squared, so that's just 5 times 5. And then we cancel 5 with 5. So first 5, so this 5 would cancel this 5, that 5 would cancel that 5. Of course, it's not really being cancelled, but when we say 5 into 5, we'll get 1 and 1, so it'll be 1 times 1. which 1 times any number is the number, right? So we'll be left with 5 being multiplied 4 times, so that's 5 to the 4th power. But we can think about it. If the multiplication law says keep the base and add the power, what would the division law say? You got it. Keep the base and subtract the power. Alright, so we could have simply said, okay, 5 to the 6 divided by 5 squared is 5 to the 6 minus 2, which would actually give us 5 to the 4th power. So again, the division law for indices says when you are dividing indices with the same base, you keep the base and subtract the powers. Let's look at the zero index law. How did we come up with it? So we're given the following example. Simplify 5 to the 6th power divided by 5 to the 6th power. So of course we're dividing, so we set it up as a fraction and we do our cancelling, right? So 5 into 5, 1, 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 5 into 5, 1. And we know that it's the same thing down here. So the multiplication signs are still there. So 1 times 1 times 1 times 1 times 1 would give us 1. Divided by 1 is, hooray, 1. Right? So that is the long way. Let us use the division law now to solve the same problem. So the division law says that we simply subtract the powers. Keep the base, subtract the powers. So then when we do that, we end up with 5 to the 6th minus 6 power. 6 minus 6, 0. So we end up with 5 to the 0 power. And none of these are incorrect. So then, therefore, that means 5 to the 0 power is equal to 1. We have just solved the same problem logically, 2 different ways, and seemingly got 2 different answers. But what it is really saying is that these 2 answers are the same, they're equivalent. So 5 to the 0 power is equal to 1. So from that, we have the law that any number raised to the power of 0 is 1. If somehow the teacher decides to ask you what is pig raised to the power of 0, it is 1. The next law, that is the power to power law. So the power to power law has to do with you having an index raised to another index. For example, let's look at this question. We have b squared raised to the 3rd power. Now, in doing it the long way, if we were supposed to do it the long way, then b squared to the 3rd power would mean b times b times b times b. That's b squared. That's b squared squared so far. So it says b squared to the 3rd power. So one more time, times b times b. And if you count it, you get 1, 2, 3, 4, 5, 6. So you'd have b being multiplied 6 times. So our answer would be b to the 6th power. The power to power law says that when you have a power raised to another power, you simply keep the base, multiply the powers. So instead of writing out all of this, I just say, okay, it's going to be b to the 2 times 3 power, which would give us b to the 6th. Another example, 2 to the 4th, 2 to the 4th power squared. Simply multiply the two powers and we get 2 to the 8th power. So again, power to power law says when you have a power raised to another power, to simplify, keep the base and multiply the powers. Let's look at another example. Some would consider it to be a little more complicated. So let's look at this question. We have 2x cubed y squared raised to the 5th power. Now, a lot of times students tend to just write back the coefficients and they multiply the powers using the power of a power law, not realizing that once you have a number, even if you don't see a visible power, it actually means that that power is 1. Any number raised to the 1 power is that number. So then, even that power must be multiplied by the power outside. So, we would end up with 2. So, the invisible one, we've made it now visible to multiply. So, it would now be 2 to the power of 1 times 5, x to the power of the 3 times the same 5 outside, y to the power of the 2 times the same 5 outside. And we simplify that. So 1 times 5, that's 5, so it's 2 to the 5th power. 3 times 5, 15, so that's x to the 15th power. And that's 2 times 5, so that's y to the 10th power. Now the question says that we should simplify, so we should go ahead and find the value of the coefficient right here. We can, because we can. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2, 5 times. So that's 32. So our final answer would be 32x to the 15th power times y to the 10th power. Let's look at a more complicated question. At least it looks complicated. Now when you get a fractional power raised to a power, the first thing that you want to do is to try and simplify if at all possible. Now we have right here a to the 4th and a to the cube. So we have same base in numerator as denominator. So we can apply the division law. A to the 4 divided by a cubed would mean a to the 4 minus 3. So that would give us a to the 1st power. And I didn't write it here. You don't have to. We write back our 3. So we're left now with 2b squared. 3a to the 1st power divided by 2b squared. Nothing is in the numerator to cancel with b in the denominator. Now that we have done that, we can go ahead, remove the bracket and do the multiplication that we are supposed to using the power of a power law. So remember, even though there's no number at the 3 visible, the power is 1. So it's 1 by 4, a to the 1 by 4 also, 2 to the 1 by 4, b to the 2 by 4, and we simplify. So this would be 3 to the 4th power, and that would give us 81. A to the 4th, 2 to the 4th power, that's 16, and that's b to the 8th power. And that would be our answer. So for this one, we do it the long way, 6 to the 7 divided by 6 to the 10 power. And we cancel all the 6's that we can. Remember, 1 6 to a 6, so we end up with 1 over 6 to the 3rd power. Doing it the long way, when we subtract, we get 6 to the negative 3rd power. Does it mean the two answers are different? No, the two answers are equivalent. 1 over 6 to the 3rd power is the same as 6 to the negative 3 power. And that's it. Thank you guys. See you.